Hello everybody. I'm going to start creating a new type of video which will involve me going through two exam paper questions, talking through what I'm doing, and we're going to take each of the IGCSE topics in turn over the next 8 to 10 weeks. So we're going to start now with motion and forces. So what I'm going to do in these videos is show you the exam question and then invite you to pause. Then you can have a go at it yourself and then press play and continue watching the video to see what I do. And then I'll move on. Next set of questions, pause the video, have a go, and then repeat. You'll notice I've got the 5th physics revision notebook open, and all these materials will be found on that notebook underneath. You see where it says past paper pull aparts. So you can work within your notebook if you have, say, a pen enabled device. Let's get started. First question. Let's see what I can actually put on this video. So part A, 1 and 2. Pause the video and have a go. Right, my solution. A car driver sees a hazard on the road ahead. The graph shows the velocity of the car from when the driver sees the hazard. So you can see straight away that they continue moving at 15 meters per second before they even hit the brake for about, it looks about like 0.9 seconds. Anyway, use the graph to determine the reaction time of the driver. You can see they've drawn a dotted line already here for you. The reaction time is the time interval at which they still travel at 15 meters per second. So it's 0.9 seconds. Calculate the stopping distance of the car. Remember, area underneath a graph, a velocity time graph will tell you the distance traveled. We want the stopping distance, so we want the total area under this, the area underneath the constant speed of 15, so that's the thinking distance, and then the distance covered while braking. So the total area is going to be, you can split this up into a rectangle and into a triangle, so let me do that. We're going to have the rectangle on the left, which is going to have a height of 15 meters per second times by 0.9, and then I'm going to add to that half, because it's a triangle. The base goes from 4 back to 0.9 here, 0.9. So it's going to be 3.1 seconds at the base, and then the height is 15 again. If I type that into my calculator, you see I'm doing this live. No shortcuts taken here. I get 36.75, and I'll round that to 3 sig fig. You can't go wrong at IGCSE with that. 36.8 meters. Next couple of questions. Let's get them both on the screen. Again, pause the video. Have a go at these. You may need to rewind the video to have a look at the graph again. Okay, my attempt. The acceleration of the car when the car is braking. This time we want the gradient. Remember, a gradient of a velocity time graph is the acceleration. So we're going to draw a triangle underneath, and we're going to think, well, what's the change in the velocity, the change in the vertical quantity, change in y, or the rise. Now we go from 15 down to 0. So it's actually going to be, the change is going to be 0 minus 15. So minus 15. And so that's the rise, as it were. And then the run is going to be from 0.9 down here to 4. So it's going to be 4 minus 0.9, which is our 3.1 seconds. So the gradient, let's stick with the same color, is going to be minus 15, or we could write the working as well. 0 minus 15, change in the velocity divided by the change in time, which is 4 minus 0.9. So it's minus 15 over 3.1, which is about 5, minus 4.8 to 2 sig fig. Note the negative sign is required. The acceleration is negative because the car is slowing down. B, the speed of the car affects the thinking distance and the braking distance. Discuss the other factors that affect the thinking distance and the braking distance of the car. So remember that the total stopping distance, if I talk around this question a bit, this is the total stopping distance. That's split into the thinking distance, which we saw above, and then the braking distance. Now, the thinking distance is affected primarily, in fact, almost entirely by the reaction time. So anything which will affect your reaction time will affect the thinking distance. So let's think, we're thinking things like alcohol, distraction, so children in the back of the car, trying to multitask, being on your phone, tiredness. So those are all things that will affect your reaction time, increase it, and hence increase your thinking distance. For the braking distance, that's to do with weather conditions, which will affect the friction between the tyres and the road, and factors which affect the roadworthiness, the quality of the brakes, the quality of the tyres, and so on. So quality of brakes, tyres, and road conditions. And I would talk about, give examples. So if it's wet or icy, that's going to increase the braking distance typically because there'll be less friction between the tyres and the road. The other thing which affects braking distance, of course, we've mentioned speed, but larger mass, the mass of the vehicle, will also affect the braking distance. Okay, so what you want to do is include the information I've written here in a long sort of prose answer, and always note for these questions the number of marks, in this case 4, and also the, you don't have to write in bullet points, but I would think to myself, let me write 4 distinct relevant points, mentioning both the thinking distance and the braking distance, minimum 2 factors affecting each. So I'd have, in this case, I'd be thinking a sentence describing 2 factors which affect the thinking distance, and then a sentence describing 2 factors which affect the braking distance in detail. Okay, so I'm not going to write a whole answer there. I've given you the physics which is relevant. Next question. So this is about investigation. So the main part of this is this question, part A. Have a read through that and pause the video and have a go at it. Done? Okay, so student investigates how the surface material of the ramp affects the average speed of a block sliding down the ramp. Design a suitable method for the student's investigation. Your answer should include the measuring equipment needed, details of the independent, dependent, and control variables, how the average speed will be determined. So, I don't know what you thought, but I'm immediately thinking, okay, we're going to use a ramp. If I'm invited to draw a diagram, I'm going to draw one. So there's my ramp, and it'll be a certain angle to the horizontal, theta. It doesn't really matter what angle it is for now. If I'm going to investigate the average speed, I'm going to have to measure the average speed. So clearly, I'm going to need to measure a distance down or along the ramp. Okay, so we're going to have a distance d, And I'm going to need to measure the time it takes for the block to slide down the ramp, that distance. So I'm going to need a stopwatch. So there's a stopwatch. Next, what is my independent variable? So the average speed is my dependent variable. So, that's the dependent variable. Independent variable is, of course, the surface material. So that could be wood, it could be glass, it could be sandpaper or plastic. So that's what I'm going to change. So what we want to do is try to include all this information. And remember, it's out of 6, so you want to make 6 distinct relevant points at the very least. So for the first material, for example, wood, set the ramp up as shown above. Hold the block at rest at, and you could label this position A. Let the block go and time using a stopwatch. So notice I've said, what am I measuring the time? Using a stopwatch, what am I measuring it with? So let the block go and time using a stopwatch, how long the block takes to move from A to B, or to the bottom. Measure this distance with a ruler. So what do I measure the distance with what ruler? Then what you want to do is repeat. So repeat this twice more and find the average time once you've got the average time, you can calculate the average speed. The average speed by using average speed equals distance traveled over time taken. I would include the equation in the explanation. Then we're done for wood. We then repeat this. Forgive my handwriting. Repeat this process for different materials. Finally, we've not mentioned control variables. We want to keep the angle of the slope, the distance traveled, and the distance traveled the same. And those are the control variables. And you could add to ensure a fair test. Now, if I was marking that, this is what I'd be looking for when I'm assigning my marks. So hold the block at rest at position A. Okay, that's probably worth the mark. Let the block go in time using a stopwatch. So we've got the quantity and the instrument I'm using to measure it. How long the block takes to move from A to B. Measure the distance with a ruler. Repeat this twice more and find the average. So for repeat twice more, and average, I would give 1 mark. Calculate the average speed by using the formula. Repeat this process for different materials, and then some mention of control variables. Okay, so there we go. There are the 6 marks I would choose. It's likely there would be marks perhaps for describing the block moving from A to B. That would be quite generous. Repeating the process for different materials, that's probably worth a mark. So you can see, you can quickly rack up marks if you are focused and concentrate on the points that you're asked to describe. You might get some mark for the diagram as well. For this question, in fact, have a look at that question. Justify why the student should display their results as a bar chart. And have a go. Pause the video. Okay. Hopefully you've had a go. The reason is that the independent variable, remember the one that we're controlling, the surface material, is what I'd call a categoric variable. Okay, it's not numerical, it's not discrete or continuous. Numerically, it's categoric. So I would say, so it doesn't really suit, for instance, a scatter plot, right? You'd only use a scatter plot if you have 2 variables which are continuous. So force and extension, or current and voltage. For something which is categoric, you would, or described by words, so plastic, wood. That's why in this case you'd use a bar chart. So the independent variable, the surface material, is a categoric variable. So a bar chart is most appropriate. And there's your mark, okay? Right, I hope that was useful. You can go back and rewind and watch bits again if you want. Next episode will probably be Hooke's law and Newton's laws. Thank you very much. Goodbye.